Hello everyone. So today we are going to solve this LeetCode problem, which is balance a binary search tree. What this question says that we have been given a root of binary search tree and we have to return the balanced binary search tree with same node values. And if there are more than one answer, we can return any of them. Okay. So what is binary search tree? Binary search tree is a tree in which left the value of left node is always smaller than the root and value of right node is always greater than the root. Okay, so for this example we can see there are two solutions. We can either make this or this. Here also the depth of this is 1, depth of this is 2, so absolute difference of 2 minus 1 is 1. Here depth of here is 2, here 1, so absolute difference of 1 minus 2 is also 1. So it if the absolute difference is le less than 1, then we have the balanced binary tree. Okay, so in this way we can make a balanced binary tree. Okay, so how we can approach this question is whatever our binary tree have been given, we can sort that binary tree. Okay, if we sort that binary tree, and what we do, we split it from the middle. Okay, and then store these values in left and right tree. Then again apply the same function on both the sides, left and right. Then what will happen after applying the same functions again and again, we will get our final binary tree. Okay, so first what we have to do, we have to sort them. Okay, we can easily sort them. We know it is a binary search tree, so doing in order traversal, we can get our sorted vector in which we have our values of binary search tree. Okay, binary search tree. Then what we have to do, we have to write a function balance in which what we do, we find the middle pointer and do do the partition accordingly in order to balance it. Okay, and third is our given function which is already given, which is balance pst, in which we call our first in order function to sort the array, and then we'll call our balance function to get the root value of that balance tree. So let's see how we code it. Okay, so first what we write the in order function, void in order. What we'll pass the root node and we'll pass the vector. Okay, now if root is not present, then we'll return from the loop. This is a recursive function, so this will be our base condition. Okay, otherwise what we'll do, left traversal, that is root of left comma vec, and then what we'll do, we'll push the middle value, push back the root of value, and then what we'll do, the right traversal. Okay, root of right comma r vector. Okay, in this manner what we'll, this will be our in order traversal. Then let's make our balance function. Okay. What we'll pass? We'll pass the left pointer which starts from 0, right pointer which starts from n minus 1, and our vector which is having sorted values of our binary search tree. Okay. And if at any point L is greater than R, we return null. This will be our base condition. Okay. And what will be our mid value? Our mid value will simply be L plus R by 2. Okay. To handle, we can also write L plus L minus 1 by 2 instead of this. Okay. So now what will be our root node? Our root node will be starting from mid. Okay. So it would be new of tree node of vector of mid. Okay. This will be our root. Then what we'll do, we'll simply do the same thing for our left nodes and right nodes. That is, we'll call this function balance, and we'll send left mid minus 1 and vector. Similarly, here we will call balance function starting from mid plus 1 comma r comma vector. Okay, and at last what will return? Our root. This will give us our balanced binary tree. Then finally, what we'll do in our main function? What was our main function is balance BST. And what we have been given in this? We have been given a root, okay, of tree node type. So first we make our vector over here, okay. Then we'll call the Inorder to get our sorted vector with our values from the BST, okay. Then what we'll define? We'll define the left pointer which is from 0 and right pointer which is from n minus 1, that is vector dot size minus 1. Okay. And simply what we'll return? We'll return the balance function, will return our balance tree. So we'll call it and we'll return it. That was our final answer. We'll get our finally balanced BST from here. That was a simple question. If you have still any doubts, just put it in the comment section, or if you have any